going to begin this talk with a warning. This talk is about the internals of the state compiler and runtime. This talk is going to be code diving. This talk is going to be discussing recursive algorithms. And this talk is going to be going over how things like extend and requisite ins and the render system work under the hood. If this does not sound like it is something you want to deal with, I will not be hurt nor make fun of you if you leave the class, the talk, whatever this is. Gareth, you just added a requisite. Okay, you didn't add it, whatever. You know this crap. Actually, it's more like you don't even need to be here. Okay. Okay. The salt state system is a little different from what you're used to seeing when it comes to perhaps a compiler. All of the componentry inside of the salt state system is data-driven. And many of you are probably already familiar with this and familiar with the fact that when you write salt states, you're really writing a YAML representation of a data set, as opposed to expressing it in a language. And many of you have probably heard my early argument for not writing a domain-specific language based purely on the fact that I don't really want to grow a beard. So, I know, I've tried. I can grow a really great beard, but it just drives me nuts. I just can't do it. Like, I see guys with great beards and I'm going, that looks so good. I should grow a beard. Anyway, sorry, I digress violently. I will follow up with a story that I told a little earlier so that you'll forgive me if I fall down or pass out. This is the fourth SaltConf. Every SaltConf so far has been 2 or 3 days long. And so at the beginning of the fourth day, the day after SaltConf, I'm always terribly sick. I've got a bad cold, fever, et cetera, that I believe comes from interacting with just a lot of people and being stressed generally out of my mind. SaltConf this year is 4 days long because we put an extra training day in. And so I woke up this morning unable to speak. So if I pass out, I'm just apologizing beforehand. I'm going to do my darndest. All right. So, diving in. The state system. I think a lot of you are familiar with the renderer system to a certain extent. Understanding that what the renderer system does at the beginning of the state runtime is go out and collect all of the relative state files that you have and pass them through Jinja, YAML, or whatever the devil you decided to write your state files in. And then that system outputs high data. This is what the state.showHighState function is showing you. The output data from the render system. So that you can see the raw data which is being sent into your subsystems or into the salt state system as soon as it's ready to go. Okay? So I'm actually going to start with gathering that information from its respective sources. Okay? And so I am in this file, salt/ or whatever, where am I? Salt state.py. Okay. Inside of this file, there is a class called state, okay? The state class is the guts of actually running the state system, and we're going to spend the bulk of this talk inside of this file. But oh yeah, it's base high state now. But the high state class is the place where I want to start. Hey, they got a whiteboard. They are so fantastic. I'm so excited. All right. So I want to start in the high state class. What we're looking at in the high state class is not the class associated with the state.highstate call, but the class that's associated with downloading and gathering multiple files and generating the high state data structure. Okay? Now, if we come in here, there we go. One of the first things to look at is the top file. Now, one of the main arguments that people give me about the top file over and over again is that they come back and they say, why are you creating environments inside of the top file, and we don't think that your environments make any sense? The main reason why I put environment definition inside of the top file was so that you would be able to define what environments systems are in on the master instead of having to configure your endpoint systems relative to their own respective environments. If I'm making a config management system, the endpoint I'm trying to configure should not need to be pre-configured. Now, and we can argue about that some other time. All right. So the first thing that happens, man, that is incredibly annoying. The first thing that's going to happen when you call a high state is that we're going to download the top file, okay? And so when we call get tops, where are we at here? Anyway, when we call get tops, there we go. The first thing that we do is go out and grab that top file from the master. And I say master, it's really going through the file client interface. So on a minion, the file client interface is an interface that allows us to connect to arbitrary file systems, whether those file systems exist on the Salt master or they're local. This interface also allows us to connect directly to an external file, a file server backend on a minion, which is why things like getfs still work or can work when you run salt call -- local on a minion, so that you can have a minion control itself completely directly out of a Git repository without any association with a master, okay? So all of that stuff is baked into the file client interface, which we initialize when we create this class. All right. So we go out there and we get the top file, okay? We go through the top files and then we merge the data sets that are inside of the top files. This is also one of the things people like to complain about is the merge order and logic of the top files. And now that's why we've got multiple mechanisms and methods that you can use to merge them differently. But effectively, that gives us the top file. All right, now after we've got that top file, what we're looking at, I'm going to whiteboard a few of these. This code's not helping. What we're looking at after we get that top file is that we create something called the matches array. The matches array is a list of the top-level SLS references that we're going to be downloading from wherever the file client is for the sake of simplicity instead of trying to express the modularity of every layer in which I'm referencing. I'm just going to go ahead and say the master, okay? All right, so at this point, we've got a Python dictionary that has keys of environments referencing lists of SLS references. Okay? One of my favorite comments about Salt early on was, Salt is not magic, it's just a whole lot of Python dictionaries. Now, this massive matches system then goes into the download or the beginning of the render system. The render system is going to pull these files in and generate a render-based order of all of the references inside of these files, which is why Salt states evaluate in the order in which they're defined inside of the file. Okay? So how this works is that the render system hits the matches list. And again, so this is an ordered list in here, and downloads those references one at a time. When it downloads the first reference out of the top file, it will render it, generating the high data. After rendering it and generating the high data, it will inspect the data set to see if an include exists. If there is an include, it will take the includes in that list and pull them in, one at a time in the order in which they are defined. As soon as it gets to a file that doesn't have another include in it, or all of the includes referenced in said file have already been included, so that we don't just recursive loop, right? Then it will take all of the references in that file and apply an order to them. So if you've got a state, say we've got temp foo, file.managed, source, I don't care. Okay. As soon as we render it, Salt inserts an order value. And so, again, that means that each state, as they're defined, now has an order value. Okay? All right, now it's going to go backwards up the pipe of the includes. So the reason why this is important is really understanding how that where that initial order comes from. Okay? So let's walk through this really quick. Okay, my top file references an SLS file. That SLS file has a list of 3 includes. Okay, it pulls the top include off of that SLS file. That included SLS file, let's say, doesn't have any includes. So then the first state in that SLS file gets the first order that we apply. Is everybody with me on that? All right. And then that order is applied sequentially through that file. Then we go back to the previous file and then the next include and then call the next file. Okay? All right. And so we have order. Who in here has used order in their state files? Joe, raise your hand. I was looking at the SUSE ones. They have order all over them. Anyway. Oh, but you don't write them. Okay. I'll be talking about how order is applied a little later. Okay. So now, after we go through and re-render all of these files, we've got our initial instance of the high state. Okay? All right. Next, the high state data set has to be conditioned. So the high state conditioning involves us running through a number of processes. Who here has used a requisite in and knows what a requisite in is? Okay, that's a better showing of hands. I'm actually really thrilled that a lot of people didn't use order, because full declarative, I guess. Order can be really useful. I didn't mean to call you out like that, Joe. Like we're still good, right? Okay. You're just checking your code? I was looking at some SUSE states the other day, and it was like, they had like a ton of order keywords in them. I don't remember where I was, though. All right. So now we need to condition the raw high state. So a lot of people have used requisite ends and are familiar with requisite ends. Has anyone ever used the extend keyword? Excellent, far fewer of you. The extend keyword allows you, say you've got an ID declaration in one state file, and then you've got another state file that says, I want to manually change the value of a state definition in another file. That's what extend allows you to do. Okay? So, that wasn't much up there anyway. I told you my clock was off. Now, what the extend, so we've got to first deal with requisite ends, and then we deal with extend. Okay, so with requisite ends, we go through and we evaluate all of the states that are in the high state data set. And we scan for all of the requisite ends. And then we turn all of the requisite ends into extend statements. Because the actual runtime, when we get all the way down to dealing with requisites, requisite ends don't exist anymore. This is one of the benefits of being able to create a configuration management engine that is able to have one solid view of the entire execution run. Is that now that we've got that high state, I can manipulate every aspect of that run relative to data which exists throughout the run. Does that make sense? Okay, I'm seeing a number of strong nods. Not like that nod you give when they're giving you a intelligence community briefing for like the CIA, and you're kind of going, we're doing what? Okay, now, I don't know what that's like. Okay, so the requisite end stage scans for the requisite ends and then adds them to a dictionary on top of the high state dictionary called dunder extend. So if you were to make an ID called dunder extend, the state system should yell at you. No one's ever told me that they've run into this as a problem. All right. And then we evaluate the extend. So the extend is now an extra dictionary which has all of these references in it. It goes through the extend and then compares it with the body of the high state and changes the body of the high state data set in line to be with what the extend says, and then deletes the extend. Okay? This is the first pass of inline manipulation of the data set. After we have inline manipulation of the data set, we've also started our first pass at simplifying the data set that the runtime is going to have. Obviously, having a runtime that has fewer things that I've got to deal with during the runtime is going to make it a lot more reasonable to execute, and it's going to make the execution significantly faster. So a lot of what we're doing in here has to do with not only making it so that algorithmically it's not a complete brain melt when we get down to the runtime, but also I'm going to argue so that the runtime and the compilation time is as performant as possible. Okay? Now, so we get past the extend statement. Next, we're going to be able to actually compile the high data into what we call low data. So high data still looks like this, right? Like what you've represented in YAML. But when we're actually executing the state run, we want a data set that looks a little different. So the data set that we want when we're executing the state run needs to represent individual steps. So many of you are probably familiar with the fact that this right here, where we say file.managed or command.run, is a direct reference to the function inside of the state, right? Which is why logically, although not necessarily all that conveniently, Salt's state system is self-documenting by its basic nature. I'm going to say that a clock is better. Okay. Now, when we get down to low data, though, what I need is a list of data sets that can be applied directly to these functions. And so this is what you see when you run state.show low state. And so this ends up being, let's see, once we've compiled it down, okay, so once we've, and okay. So once this goes through the process of low data compilation, it would look like this. All right. Who here has used the names keyword in Salt? That's pretty good. So you've probably noticed that when you use names and you run your states, the end result is that you've got multiple individual states that came out of that, right? So the low data compilation is also where names gets extended. So while we're iterating down through this data set here on the high data, every time we come across names, we stop and we insert a new order for each of these names as they're listed. I know, except for like that bug that was introduced in, I think, 2016.3. 2016.3. Anyway, sorry. We introduce a new low chunk, as it's called in the compiler, for each name definition that we have. Okay? So names becomes a shortcut for you to just create completely replicated instances of the same state. And very, very raw, we're just making replicated copies of the same state. Okay? People comfortable with me still? Most of your heads are still up too, like I'm not totally losing you.
Use a darker marker, like blue or black,
I want to make it very, who said or type it or text on a laptop? I want to make it very clear I'm listening to that guy and not Dave Evans. So I've known Dave down here for years. All right. is actually one of those instances where I'm now suddenly debating how I should type this in. All right, so if I've got a state that looks like this, whoop. All right, look, I'm typing onto a whiteboard. Y'all are going to get what you get. It's a demo. I mean, it's not even a demo. All right, so that YAML representation, when it gets compiled down, yeah, it gets compiled down to so the state is the file, right? Whoop. If somebody tells me that they expect this to be like proper JSON, you can just leave. Fun is the keyword that we use for a function. And I'm gonna admit publicly that I screwed up on the internal referencing of these variables. In that source is inline with state and fun, which is why state and fun are internal keywords and cannot be used for state function arguments. Okay? Now, like I said before, we also insert an order. Now, one of the things that's tricky is that the order starts at a high number. Actually, what the order does is before the order starts getting inserted, we do scan through the high state and see if you have any existing order definitions. And make sure that any order definition is going to be a significantly lower number than the order number that we start with. Okay? So that we would never collide with any of your existing order definitions. Subsequently, you can say order last to put something on the end, or order -1, and so those just get applied order-wise, inserted on top of the order at the end of the order evaluation in the low state compilation. Okay, and I'm missing one thing. We're still good, right? All right, now everybody's comfortable with the name and ID construct, I'm going to generally assume. Actually, I won't assume that. I'll just say it right here while I'm typing. And yeah, okay. So as you can see, temp foo is the ID declaration, right? The ID declaration is copied into the name field. If you explicitly define the name field, then ID would be temp foo, and then name would be what we explicitly defined it as. This allows us to have requisites which are relative to the ID or the name. Okay? All right, you happy, Dave? You happy, highly esteemed gentleman with a perfect beard back there? Not like Dave's beard. Okay. Oh, come on, I control people I know in talks. All right. And so subsequently, if we had names in here, we would have multiple instances of this, this low data. So the low state is a collection of low chunks. Okay, so each dictionary is a low chunk. Once we're actually through with the low data compilation, then I will pick up a black marker. Sorry, I've got a habit of picking up the medium colored markers because they're always full. Now, all right, then we sort. So at this point, I've got an ordered list that is finite and linear, okay? Right? All right. And so since I have a finite and linear ordered list, I can sort it. And so we sort it based on the order value, right? Pretty obvious. What if somebody, while writing their states, created two states that had the same numeric order? Because I allow you, the human, to put an order value in, right? And if I'm going to allow you, the human, to put an order value in, I need to assume that you, the human, at some point are going to screw things up. Okay, so we sort first on the order, and then we fall back to the lexicographical sort of the combination of the state, the function, the name, and the ID combined together. For any of you who were using, was anybody in here using Salt before not.17? You people are awesome. Even Joseph. Yeah, and you are awesome, Dave, like most of the time. Now, before not.17 is when we introduced automatic insertion of the order keyword, which means that before that, states were not evaluated in the order in which they were defined in the file. Before that, we only used the lexicographical sort, which meant that quite conveniently, service just always happened to come after package. And quite inconveniently, file just happened to always come before package. And command always came before package. Okay? But back then I was still hanging on to the argument of dudes, make all your stuff declarative. But then got the order sequencing in and Salt became significantly easier to deal with. Or I should say, Salt made what feel like potential ticking time bombs, which is the fundamental problem with having an imperative definition of defining the state of a system. Because as soon as you compromise the order that you have implicitly placed inside of a file, then the execution of your system changes and boom. Which is why doing things in a declarative way is fundamentally a better approach. But whatever. At the end of the day, my objective isn't to force you to follow a dogmatic view of the world. It's to say, here are some tools to solve your problems. Or to fight your problems. Now, so now at this point, we've got hopefully a, made it in time. Now at this point, hopefully we've got an understanding of how we've gotten to low data, okay? Now we get to have some fun. Because now that we've got low data and that low data is sorted, we get to go through the execution runtime. Now, how the execution runtime works, oh my goodness. What? put a little muscle into it. There, see? Muscle. It's not helping very much. All right. Now we start the runtime. So let's say that I've got a low data set with 7 things in it. It's been sorted according to their order so that we know that it's going to run in the same order every time. And I just lost the word. You know, the word that means that it always runs the same way instead of not running the wrong way. What? No, idempotent means that you run the same function every time, and then the output including all modifications to the system. Yeah, it's deterministic. But yeah, good job, good job. Who said deterministic? You guys are awesome. I should just listen to the German over here. Okay, now. Okay, because if you write software that is non-deterministic, you're fired. I'm making no reference to any historical software written by any of my competitors. Now, there is evaluation order and there is execution order. So let's say that we go to number 1 and it has no requisites. Great, done. We execute it. Then we go to number 2, but number 2 requires something. So then we go into the requisite loop. The requisite loop then says, okay, number 2 requires something called cheese, which, you know, requires X, something named X. Because obviously the requisites aren't evaluated to order. That would be a 2-pass pre-compilation, and I didn't do it like that. So it quickly goes down the list until it finds the requisite. Executes the requisite, returns, and executes 2. Okay. So if that's how we handle a require, how do we handle a require in? Anyone? What? Thank you, Thane. We pre-resolve require in. It doesn't exist in the runtime. All right. So that's pretty cut and dry, right? We have a require, we find all of the requisites, we run the requisites, and then we come right back, right? It's a pretty cut and dry algorithm. This is how it works for all major requisites. Require, watch, on changes, and on fail. So the follow-on question becomes, how do we evaluate PreReq? So requisite's pretty straightforward. Let's say that we get to 3. And 3 pre-requires 7. Who here has used PreReq before? Who here knows? Holy smokes. I worked really hard on this, guys. Okay. I made somebody else work really hard on the documentation explaining what PreReq is. PreReq allows you to say that PreReq allows you to say, I'm only going to run this state if this state that hasn't run yet is going to make changes. Okay, let me say it again. I'm only going to run state A if state B, which hasn't run yet, is going to make changes to the system in the future. Now, why would you need that? I did not let you in here. You came in of your own accord, Don. Yeah. Yes. Let's say you're about to make changes to a service and you don't want the you need to shut down the service before those changes are made. Let's say that you want to make sure that an Apache server is gracefully shut down and removed from the load balancer before you update the code, instead of introducing any inconsistency to a client who might reference that code during the time at which it is being changed on disk. And so you would only want to shut down the Apache server if you are about to make code changes, right? Or you would only want to notify your load balancer if you're about to make code changes. And so PreReq allows you to just magically know. So how's that work? That's kind of dizzying. So if 3 requires 7, or pre-requires 7, then back here at the load data compilation, we pre-checked all of the pre-requires. Okay? Oh, sorry, I just lied. Right here at the requisite ins level, we pre-checked all the prereqs, because a prereq is also a requisite in. And so prereq in is a requisite in that creates a requisite that is also a requisite in. I was waiting for you to say that. Okay, it needs a prereq because what does a prereq do? Do you remember? A prereq tells the compiler to modify another state. Sorry, a requisite in tells the compiler to modify another state. So when I say prereq, the requisite in system says, I'm going to leave the prereq definition there so that this still says prereq. And then the thing that it prereqs, I'm going to give a new requisite called PreRequired. And so therefore we protected ourselves from the gate, because what if 6 prereqed 4? Well, 4 would be evaluated first. But we can't have that. Because if 4 is going to change code, I would have to execute the thing that was later in the order sequence before I executed 4. Does that make sense? Okay. And so that means that if we got to one of these and it was pre-required by something else, then that pre-required would mandate that the thing that prereqs it is evaluated first, just like a requisite. Really, the problem with PreReq is adding in all of the necessary relativistic gates. Now, so prereqs have been evaluated into a via requisite in statement to make a copy of, or to make a fresh requisite, which doesn't get applied by the user to a remote state to ensure that this state is never run before this state. But then the next problem that we run into is that I have to find out if state number 7 is going to make any changes to the system before I run state number 3. So to do that, I then have to evaluate all of the requisites of number 7. So if number 7 requires number 6, then I've got to evaluate number 6. Because otherwise number 7 isn't going to give me an accurate view of whether or not it's going to make changes. Does that make sense? It does. Yeah, it was a long afternoon. Now, okay. And so 3 scans 7. 7 requires 6. 6 is run in full. And then 7 is run, and we manipulate it to run with test equals true turned on. Yeah, I'm almost out of time. How convenient is a giant clock? I'm doing a Q&A session after this, so I don't have to wait and let you ask me questions. You can ask me in the next session. Now, so it runs number 7 in NOAA in test equals true mode, so it doesn't change the system, but returns if it's planning on making changes. If it's planning on making changes, it runs 3, and then after it runs 3 and has evaluated the prereq, what state do we run next? Who says 7? Who says 4? Right. Thought for sure. I could have sworn somebody over there was like 7. Duh. I'm looking at it. It has to be next. Yeah, no 4. And then we see the 5 and 6 have been run. We run 7. Okay. I'm out of time. I must admit that this room, 250 AD, sorry, BC, this is 250 BC, is way better than 250 AD. Just like in real history. All right. I have the pleasure of at least saying to everybody, thank you for coming to SaltConf yet again. There's only one session left in this conference, and that is the Tom Q&A, which is in a different room. If you want to troll me and be a jerk to me during the Q&A, feel free to leave now. Otherwise, we'll have the open Tom Q&A, and I think it's 251 FD or something. Just thank you, EF. But other than that, thank you very much for coming to SaltConf. I have thoroughly enjoyed spending yet another conference with many new faces, many old faces, making many new friends, enjoying old friends, and occasionally bumping into old enemies. Actually, that hasn't happened this year, even though Dave Evans is sitting in this audience. So I'll, what?
I'll remember that one.
You'll remember that one? I trolled you a lot in this, like we're cool, right? No? He does the same to me. Okay, so thank you very much.